Okay, we're back, engineering fam. I'm telling you, man, it's a conspiracy, man. It's a conspiracy.
We're back, engineering fam.
Once again, we are doing a. Sorry, echo.
Once again,
We're doing a July tabular series. We're gonna be doing a little bit of clustering. Let's get back into it because I want to start. Like, share, subscribe. Like, share, subscribe. All right, before I got started, I got cut off, so I'm just gonna go over this real quick. Give me a moment. All right, so we're doing the July tabular series. I hope they're set up right. I hope it's set up right. I hope I didn't get the wrong thing. Okay, I got the right one. Like, share, subscribe. All right, okay, so in this challenge, we're given a data set where each row belongs to a particular cluster. Your job is to predict the cluster each row belongs to. You're not given any training data, and you're not told how many clusters are found in the ground truth labels. So we're going to be predicting the cluster each row belongs to. Okay. So, that is our series. I think I need to download the actual data because I don't even think I did that yet. I think it's the same thing though, data.csv. Either way, I'm gonna download it. I think it's the same thing, but either way, we're gonna go ahead and you know what? I wanna start a folder. It's good to keep these things a little more organized. It's called TPS July 2022. And of course, we gotta have sample submission. And we're just gonna unzip them in the actual folders. I'm just doing this real quick in there. All right, so we have our data.csv right now. You guys can't see it, and we have our sample CSV. I'm gonna upload them as well. We got a blank notebook. First, let's go ahead and upload our data. I think all we need is data.csv. Yeah, we know. All right, let's make sure our data is there. Refresh that. Oh, it's still uploading. I'm sorry. Is it done? Okay, it's there. There's our data. So we're gonna be, you know what? We're gonna be start with a little bit of LGB. LGB is actually light gradient boosting, and I actually got, because last time we used XGB, which is extreme gradient boosting. Okay, and they work a little different. I kind of just pulled this from Neptune blog, but just to get the difference. Gradient boosted trees, GBDs, are one of the most popular choices of machine learning algorithms, 100%. XGBoost and light GBM are based on GBDs, have had a great success both in enterprise application and data science competitions. Okay, so in XGBoost, trees grow depth-wise. Okay. While in light GBM, trees grow leaf-wise. So it's per leaf, and that's per depth of the tree. Okay. Which is a fundamental difference between two frameworks. XGBoost is backed by the volume of its user, like I said. that results in enriched literature in the form of documentation, resolution issues. Okay. While Light GBM is yet to reach such a level of documentation, I think Light GBM is a little newer. Okay, both algorithms perform similarly in terms of model performance, but Light GBM is probably faster. Yeah, exactly. But Light GBM training happens within a fraction of the time required by XGBoost. Yeah, XGBoost takes up a lot of computing power, 100%. And you can tell. So Light GBM is definitely faster, and yeah, XGBoost requires a lot of resources to train on large amounts of data. And I don't have a supercomputer; I have a little MacBook, so we will not be, doing large amounts of data. But I mean, this database isn't that big anyway, so. Which makes it an accessible option for most enterprises, while Light GBM is lightweight and can be used on modest hardware. Light GBM provides the option for passing feature names that are to be treated as categories and handles this issue with ease by splitting on equality. Okay. H2O, I think. What is H2O? I think that's their thing. Implementation of XGBoost provides the above feature as well, which is not provided by XGBoost's original library. Hyperparameter tuning is extremely important in both algorithms, so we already know that. We'll be doing some hyperparameter tuning a little later on, but right now I am going to be just implementing this Light GB algorithms. I pulled this from a notebook on Kaggle. And I just want to, I posted actually the link in the description of my YouTube. And we're going to try this really quick. Let's go ahead and just edit my copy so I could just go in a little easier. Because it's a notebook in itself, so. Anytime. Okay, so a couple of things were important. Obviously, NumPy, Pandas, GC, gonna be doing sklearn, and of course Light GBM. So let's go ahead and just copy. All right. Oh wow, what are we doing? What are we doing? You know what, let's copy. You know what, let's go back. For some reason that's copying the whole thing. We just want to get started. Oh, like, share, and subscribe, Nick. Really quick. All these damn windows open. I'm about to start closing some of this crap. Share a couple of these things. Go ahead and share this. If you're watching this live, leave a comment. If you're watching the replay, share. I must appreciate it. Yes, sir. Yes, sir. Right. Either way, I'll be shooting this out mañana. Come on, you slow bastard. Alright. Close that. Everything is killing my computer. What happens when you Please stop hating. I love this shit. Yeah, man. All right. So let's go ahead and get started. Let's do a little bit of data science. All right. So we are going to go ahead. All right. There's a few different things, man, we're going to be doing in here. Start a new cell. All right. So we're going to be creating a seed function. All right. I don't know if I need 2022, but or is that just the year? No. They got 2022 for whatever reason. We're gonna be creating a OS environment, and we're gonna be creating random seed. Of course, it's gonna be 2020 seed everything. We're gonna be doing oh god, what's it called? Info cross fold. Hold on. That sounded crazy. So there's gonna be 10 folds and there's gonna be 7 clusters that we're gonna be testing for. Right? As you can see. These are the type of things that we're gonna be doing a little later. Alright. Seed everything. Seed everything. Because remember, we're trying to find the actual rows of the clusters. So we have no idea how many clusters there actually are. All right. Then we're gonna start importing our data. All right. And this is a good this notebook that's available is good to get you started. And by the way, we've been playing Rainbow Six live as love, nigga. All right. Without you getting better. All right. Tabular playground set. We don't need that. Let's go ahead and get this half. Train. Oh, good thing I want to show too. So we're creating our training set right here. We're just basically normally reading our CSV in here, but we're also going to be dropping this ID row because we don't need it. It's all we need is just the numbers, and it's gonna automatically create an ID anyway. And then our columns are just gonna be a list of the training columns. So let's go ahead and get that popping. I'm not, as you can tell, I'm not mounting my Google Drive this time because I don't really need to. These are super small files, so they're not really gonna be working that much. All right, we already got a nice error. Not found in access. Matter of fact, let's see. One thing you'll learn about data science that's even more important than the machine learning algorithms that you're going to be implementing is EDA. EDA is called exploratory data analysis, okay? You need to look at the data before you start doing anything to see how it's separated, see how it actually operates. Okay. Train. Let's put in a new one. I don't want to keep importing that. Okay. So you can say this is our data right here. So they don't even have an ID row. They have row ID. That's why. Yeah, okay. That's why. So let's try this. Row ID. Access 1. Kernel. Boom! Alright, this should take a little bit of a second. Nick! breathe in. All right. Now it should be training without role ID. There you go. We got rid of our ID. We don't need it. All right. Just really quick, I want to just see the top 5 roles right now. I'm guessing the F is for gender, probably female. Okay. Also on this one, I'm going to be doing more data viz. We haven't actually done as much data visualization as I've wanted to. But for this one, I definitely want it to look a lot better. Because a lot of times I could throw numbers at you. I could throw numbers, and when you all start doing this in the real world, you start dealing with stakeholders, these people who's high up there and doing all this good stuff. They're not gonna want to read all these numbers. Nobody knows what this is. Oh, I see a null value right there. We're gonna be getting rid of those. But yeah, you want to do data visualization. I believe we got Seaborn downloaded, right? Or sklearn. We got sklearn. We'll download maybe Seaborn or something for better data visualization, so you can see this. Like, you can make 2D models, you can make 3D models. So, you know, we gonna be going in. Okay, so now let's make a copy. And okay, so how are they determining the best? Okay, let's make a copy first before we even get started. All right. Make a copy of our training data. So we're going to, this is a min-max scaler, and we're going to fit transform. We're going to train the scale columns. We're going to use the best data from these particular columns, I should say. F07, 8, 9, 10, 11, 12, 13, 22, 23, 24, 25, 26, 27, 28. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 different rows, or 14 different columns. Now that I believe it is up to you which ones you can use, but right now we're just gonna go straight down the list. Let's get all those columns. Nick! Sorry, I'm retarded. Don't hate me now, cause you ain't me now. Alright, we're gonna take the best data from these columns. But first we're gonna fit this. We're gonna use Power Transformer. I've never actually used Power Transformer before, so let me go ahead and look that up, cause I've used min-max scaler, you know, hundreds of times. But this might take a second. Because we're fitting the data. So before we even start looking up Power Transform, or not Power Transformer. Power Transformer, sklearn. Okay. Power transformers are a family of parametric monotonic transformations that are applied to make data more Gaussian-like. Okay, so it's gonna normalize the data, right? Basically, when they say Gaussian-like, they're gonna make it as close to the bell curve of the Gaussian model, which is a normalized data set, as possible. That's gonna take some time. I hope my memory doesn't run out. You hate Naz, nigga. All right. Come on now. It might take a minute. Because we're fitting this data. Anytime you're doing fit, you're trying to fit data, you know. Depending on your... Well, it's really your GPU now. Because I'm using Colab. It's all in the cloud. But it goes off your GPU. Or at least it's supposed to, so... We are going to normalize this. Oh! Cook. Sorry, I'm on my whole shit. Cook. Oh my god. Okay, it finished. Okay. What is best data though? I wanna see what it actually looks like. EDA. Should be a bunch of a list of okay. Alright. So as you see, best data is just a list of all of these columns that we want to use. Right, but we still don't know the best data is yet. All right, so Bayesian gigs. So this one is actually gonna put us in a Gaussian mixture model. Okay. Google's gonna be able to explain it better than me. Gaussian mixture. There it is. All right. Class. Okay. Okay. Gaussian mixture models is a probabilistic model that assumes all the data points are generated from a mixture of finite number of Gaussian distributions. Basically, gonna guess the Gaussian accuracy. So yeah, we're gonna be definitely getting into some data visualization, as you can see right here. Okay, so it's a package. This Gaussian mixture model is a package which enables one to learn Gaussian mixture models, diagonal, spherical, tied, and full covariance matrices supported. Sample them and estimate the data. So you're gonna be estimating, finding your predictions about the data using Gaussian models, which of course, as I just said, is a normalized distributed data set. Okay, facilities to help determine the appropriate number of components. So at the end of the day, we're doing component analysis. What's component analysis? Component analysis is when you have your data and you're trying to see which clusters of data points are so concentrated. It's enough data points that are close enough to each other that they form a component. So they are a major component of our data set. This is how we get into predicting the clusters. Okay? Alright, so we're doing Bayesian mixture. Number of components equals number of clusters. I think the number of clusters was 7. Okay, number of clusters is 7. Let's use covariance. I'll move, bro. Gonna do max iterations 100. Random state equals 1. And in a init. I think that's the number of... What is internet? What is internet? Let's see what it is. You can look at the documentation a lot of times to see what it is. K-means. All these different initialization methods. I think it's number initialized in component. Keep in mind, I had to do all this shit on paper last semester. It was terrible. Oh, thank God for Python. Terrible. Terrible. Let me see. Google's your best friend. and it. If a callable is passed, it should be take in arguments in cluster to any random state and return an initialization. Default equals 10. So we're running initialize clusters. So it's and there's a number of initialized clusters. So we're going with 5. Then we're gonna fit it. Then we're gonna predict for the training set for best scaled. And then we're gonna predict the probability for BGM. And we're gonna fit that as well, right? No, we're not fitting that. We're just predicting it. We already did our fit. And on a training scale. So we're gonna use it. We're gonna We're gonna predict the probability. We're gonna predict. Wish I had a little bit better notes, but it's okay. BGM predict train scale, the best data, and then we're gonna create another variable, predict probability. Let's go BGM. We're gonna predict the probability on the training scale data as well. Okay. Go. See if my computer is gonna be able to run this. We're doing 100 max iterations. Let's see. Hopefully it doesn't crap out. First of all, let's save it just in case, because I do not feel like doing this whole shit again. None of the index F7, blah blah blah. Are in the columns. Data. None of the index F7, blah blah blah, which are in the column. What do you mean they're not in the column? Train scaled. I get it. None of them are in the columns. The fuck? Okay. You know what? Let's try this min-max scaler really quick. Or maybe that's what I think I'd have to go back. I might have to run this again to get my good data. Alright. This time we're going to use a min-max scaler instead of a power transformer. You see how much faster that was? Not found list, ensure index key, missing mass on 0, unique. Uh-oh. Should have columns, right? Yes. the best data isn't there, but it is though. Stations. What does that mean? Not found equals list. Ensure index key. Missing mask. Dot non-zero unique. Of course, Stack Overflow. It'll give me the answer I need. No. Look at our shit. Ah, 10, 11, 12, 13. Okay, what do we have? 10, 11, 12, 13. What are you talking about? Okay, so how about this? Let's change this from... Does it have... I hope it doesn't have to be capitalized. If it has to be capitalized, I'm gonna be pissed off. Let's try it. No. It better not be. If it's a typo, okay. But it could also be because the row or the columns aren't where they need to be. Nope. F8. I don't even see an F8. Do we have an F8? 80 columns. Just let me see the first. Okay, I see. I don't even see that. Okay, so let's do this. Let's start with F10. Is there a F28? Oh, I see why. Look at the numbers right here. Look at the row of the columns right here. All right, so let's do this. Input contains 9 infinity or too large for type. At least it's a different there. All right. See, it's the rows aren't 1 1. You see what I'm saying? Like it's F_1_0. But this is just F_10. It should be like that. All right, so this is what we gonna do. We are going to take, how many did I have? Like 13, 14 last time? Just a random. Okay. Alright. Now we still gonna have these null last values. I have to get rid of those really quick. Still gonna give us an error because it has, yep. So really quick, I want to get rid of some null values. Hold on. I got my old notebook I can borrow that from. Memory imputation. July, June. All right. I know for a fact, and I got that in my last notebook. Yep. I want. Probably need to get rid of that before we even need to get into this. So we're trying to get rid of these null values. I seen that in the beginning. I was like, yep, there's these these null values. You know what? Let's move this down. And this should be trained, scaled, 0 roll. This might give me an error as well, but we just want to see if that'll work. Right, missing data. 856,312. Okay. Oh. All right. So, really quick, I just want to. Okay. So use a min-max scaler. Because power transformer estimates the gauge of value. Go ahead and run that again. Like that. So it's gonna take a second. Like, share, subscribe. Cheap cheap advertising. You know how we do. We ain't shit. Yeah, man. Damn that. While that's going, we want some better music. We want to get some dancing music again. Fuck the haters. See, I may have to redo train scaled again. Well, I really haven't done anything to it except fit it. Use this power transformer. Should take about 2 to 3 minutes, maybe. Oh. Again. Looks like the thing is man, the bigger value is too large for type. Float 64. Type full, blah blah blah. You can see not every algorithm is going to work. Bullshit. Is there a F underscore? Alright, but you can see we have 856,000 missing values. Okay. I think I did, what would I do? We did arbitrary frequent. Right now, I just want to, there's different ways we can impute this, right? Because if we got, let's just try, okay. Try statistical imputation using the mean. We'll make this, gonna copy this, do that. Okay. Data maybe. That let's just go line by line. Okay. Using the mean. Standard deviation.
Let me show you something.
Count. Random, try to get random int to get the standard deviation. 4. I think this is only one column. All right. Now we have 0. Now let's do XDF. Let's try it. Just going by column, one column. Nope. Not flow bullying around. Man, if you don't get the fuck up out of here. It's nice doing this live. Will you get stuck?
Let me show you something.
Okay. How do I actually... What would be a good way to remove all this? So even though XDF removes all the nulls, it's still not gonna let me do it.
Let me show you something.
Getting your model to work is the fun part, isn't it? Infinity or value too large for data type float 64. I should just do one column and just see if that one column, it might be a scalar thing. Underscore one. So I'm just gonna do this first column just to see if it makes a difference. I'm gonna fit the best data from that and see. I don't want it! I ignore the haters. Okay. Still doing this thing. Probably eating up all the RAM. Look at it. Yeah, I'm using 519 gigs of the 12.6 I got. Almost at half.
Let me show you something.
I wonder if I'm gonna have to do column by column in terms of actual getting my clusters. Hopefully it doesn't take more than 5 minutes. 5 minutes! Keep still. Come on.
Let me show you something.
Right? That finished. Right. Test data. What contains non-infinity or after. Float. This is a different error. We got a different error. Okay. Ensure index key missing. Why do I do index key? Maybe. That might not immediately. Key. Where are my keys? It's gonna be a valid key. There should be only one.
Let me show you something.
What is the key? All the way down to 856,177 values. Name. Shit.
Let me show you something.
We have the XCF and we have the this data is the one that has all the nodes. Which, okay. 19 features and score improved. Maybe I have to just drop a bunch of features, honestly. That's essentially what you're doing, right? How about this? For this best data, starts with F1 and it goes all the way to 414. It's like 88 or something. I think we need to drop a whole bunch. Okay, so this button. How about this?
Let me show you something.
How about this? Look at this drop. A bunch of them. Bunch of them. Two, three. You nigga. Four. And then let's do some other random ones. 2, 1, 2, 2, 4, 1, 4, 2. How many did I have? Like 13? Let's see. 3, 1. 3, I don't know. 5.
Let me show you something.
3, 6. Do this again. I'm reaching my RAM limit. We gonna keep going as long as the RAM stay up, but takes up a lot of memory.
Let me show you something.
Alright, we're almost at our limit. Google's like, hell no, motherfucker. Alright, alright. While this is doing this thing. Like, share, sub. I don't know if our memory is gonna last. We're gonna see. Documentation.
Let me show you something. Should be best data, right? Let me show you something.
Value too large for float 64. Slow it down. Like Stack Overflow. Alright, I'm using Scalar having problems with the affinity propagation I built in the input matrix and I keep getting a bit error. Yeah, I have one, I need it's false. True. Infinite, true. I think I have infinite values. Okay. This might happen inside Scikit, and it depends on what you're doing. I can recommend reading documentation for the function you're using. You might be using one, which depends on your matrix being positive, definite, and not fulfilling that criteria. You want to check whether any numbers are none, and not whether return value of any function is a number. So yeah, it's non. Okay, I'm going to try. Let's do it.
Let me show you something.
If it's false. So I know I have non-values. Let's check the non-values first. Obviously not gonna work. Mat. Wait, what is it? What is matrix?
Let me show you something.
Well, see if we can try resetting it. I don't know if that's gonna work. If he's doing a matrix. But this was crazy though, because I encountered this issue many times. Blah blah blah. Okay, if it asks the column, if it asks the index as a column, because this is what it does. Let's print it out and see if it asks that index. Because right now it doesn't have one. Okay, it added the index level 0. Okay. So it adds level 0 and index.
Let me show you
So
something.
how about data and valid key. How about this? 1. Nope, valid key. Okay. Valid key. Maybe I should look at the documentation for like GPM.
Let me show you something.
Is this election? So we're trying to break this data set up, right? And we're trying to drop all this crap, but not working. Mixture of gauge and models. It can also draw confidence ellipsoids for multivariate models and computer Bayesian information criterion to assess the number of clusters in the data. A gauge and mixture fit method. What am I using? Gauge and mixture. Yeah. Gauge and mixture fit methods provided that learns a gauge and mixture model from the trained data. Given test data, it can assign to each sample the gauge and it most probably belong to using the gauge and mixture predict method. The gauge and mixture comes with different options to constrain the covariance and differs classes estimated spherical, diagonal, tide, or full covariance.
Let me show you something.
Types. There's that crossfold types. There's the type. 0.26216 seconds. My ass. Okay, hold on. So I am definitely having trouble with these non-values, null values.
Let me show you something.
I think I already tried, but hold on. It's been a long day, folks. What do you want me to do? Alright, 2D array. Got 2D array, got 1D array. No. God. I'm not reshaping because it's still using. Because I remember I reset it. Fucking with me. Actually, you know what? I'm gonna do the min-max scaler. All right. Expected to array got instead. Getting your models to work, baby. More than likely for the next one, I'm going to. Well, I'm gonna see if I can get this light GBM to work. But for now, it's not cooperating. Covariance type full. Gauge, and mixture. Let's look up, I'm gonna go to the documentation first. Gauging, mixture model. Ooh, got a TDS one, but I know we just want to look at the documentation. The circuit. Okay, number of mixture components. Okay, covariance type, strings, describing the type of covariance parameters must be one of. Each component has its own general covariance matrix. Each component has its own diagonal. Each component has its own. Hi. Duration. Okay, we got full, max erasers, random state. Alright, let's go line by line. Okay, so now we got our Bayesian mixture. We're trying to fit it, right? We want to fit it on the best. Come on, best data. This is not going to work. That's the point. Okay. Key error. What the intent is non-infinity value is too large. Now, what do they say about that? And that is the.
Let me show you something.
Alright, hold on. Okay, hold on. Hold up, wait a minute. Yeah, I want to just go straight to the code. I'm trying to. Truth be told, you're gonna be learning data science. You're gonna be learning as you go. To be honest, and kind of use what works, what doesn't. But what you don't want to do is just copy and paste code, because as you can see, not every model is gonna work like with this, and it can be frustrating. It's these non-values that's killing me. I can see the non-values actually on there. You know, and hold on. There it is. You know, you can see the non-values actually there, but maybe I should be getting. Maybe I should be getting the best data. Let's try that. Instead of just the scale training data, let's try the best one. Yeah, that's not gonna work. Yeah. Ooh, this whole ass niggas comment, nigga. Ain't no goddamn moderator. Let's see. People truly don't know how hard it is to code live. But let the haters hate, nigga. Let me see. Should I just put maybe XDF for the best data then? And then just remove it from the best data instead of just one column. Value is less than or equal to 0. What? No. Let's not do that. No, that's not what I wanted to do, but God. Stress. Okay. Count non-age XDF. It won't be. I gotta get my shit back. Hold on. No. Okay, hold on. So let's do. I don't want to get too far into it because I know I'm gonna get deep trying to do imputation methods, and I know that I'm gonna get deep trying to figure out why or how to get rid of these non-values. And I might just need, because I know my mind's gonna go crazy. I know I'm gonna go crazy. I know I am. What time is it? Let's see. Woo! Been on here for an hour and 25 minutes. My brain is already fried from it not working. I left some of the links in there. I think we're gonna go ahead and try a few different methods this time. This time we did not have too much success in applying this algorithm. I guess it is what it is. As part of the data science game. Hold on. Look at all these beautiful errors I got. Oh God, it's so wonderful. So lovely. You know what I'm saying? Let's clear that out for a minute. What the hell is this? Oh, okay. This is getting the missing values and the duplicates. There are 856,177 rows and 82 columns. Missing values 856,312, and there are 0 duplicates. Okay, so here's what we gotta do. Right, let's go ahead and comment that out. We're gonna stop right here. Let's comment all this out. Right? Let's comment all this out. And we need to work on these non-values, NaN, aka null values, in our data set, because it's not going to let us go any further with light GBM. And I really want to figure out how to use this. I've never used like GBM before, so I definitely want to figure this out. So okay, so let's go ahead and stop right there, cause my brain is fried. You whole ass nigga. All right, engineering fam, go ahead and like, share, subscribe this. I'm thinking we're gonna do probably one more. I'll probably do one on Sunday or Monday this week. Yeah. So, you know, definitely stay tuned. I'll be sharing it on all the platforms. Please go ahead and share, comment. Fuck the haters. Probably gonna mess up the algorithm, but you know what? At this point, who gives a shit? And I'm tired. No, okay. Going crazy while coding. All right, that's gonna be it for this Kaggle competition for July 14th. Stay tuned for more. Thanks again, engineering fam. Oh man, go ahead and check out all my social media. I appreciate it. More to come. We're gonna get through this. We're gonna figure this out. Thanks for tuning in. I appreciate the love and support. Go ahead and get coding, and as usual, go make something cool. Peace out.